Okay, today you're going to be using trig identities to find equivalences, meaning things that are equal. So if you remember these, try and find something, anything really, that is equivalent to these. Okay, just using various identities. These are just a couple that you could have come up with. Cotangent is cosine over sine. You could also add 1 over tangent, etc. This one here, there's not much more you could do besides 1. There are, but it would make it really complicated. Cosine squared is 1 minus sine squared. You could have 1 over secant squared. There's all these different ones. And tangent squared is secant squared minus 1. So anytime I see a squared, I generally think a Pythagorean identity. So you need to start thinking that too. All right, so what you should have memorized, if you don't already, is your basic trig identities here. What sine is, what cosecant is, and etc. Tangent is sine over cosine, cosine over sine, and all the ones associated with this one. So all the ones that we did yesterday, which was like cotangent squared plus 1 equals cosecant squared. Okay, also, and I did that by dividing by sine squared. But you could also divide by cosine squared, and it would be 1 plus tangent squared theta equals secant squared theta. Or A. I guess I mixed between my A's and my thetas. They should all be the same, regardless. So you do need to remember those. And what we're going to be doing is called evaluating trig identities. And that just means we're just going to prove that one side equals another. We've done this with algebra before, but now we're going to start doing it with trigonometry. These are some just basic things to try. No particular order. Notice they're not numbered, but these are the things we generally try. First, we put things in terms of sine and cosine. So if we have a tangent, we're going to put it that. Do any math. So you may have to add, subtract, multiply. And use a trig identity to find an equivalence. Do not switch sides. Everything stays on the same side. So that's the idea. So if you see a squared, use the Pythagorean identities that you should have memorized, or you are memorizing. Okay? And your goal is to make things simpler. So if you have this is simpler. Sine squared is simpler. But if you have sine squared, this is more complicated. So try to make it easier, not more difficult. So here we go. So the first thing generally we like to do is put things in terms of sine and cosine. So I want to prove that this side is equal to this side. So what I do, I generally ignore one side altogether. So I'm going to ignore the easy side because it's just one thing. And I'm going to try to make this side equal that. So tangent of B, I'm going to put that in terms of sine over cosine. Cosecant is 1 over sine. So putting these two in terms of sine and cosine, remember they are being multiplied together. So when they're being multiplied, these two are exactly the same. So it would be sine B over sine B, which is 1. Those go away, and I'm left with 1 over cosine B, which is secant B. So our goal is to get one side equal to the other side. And that's it. So without switching sides. So with this one, same idea. You can switch both sides, but I tend to try to get one side equal to the other side without switching this side. But obviously I can make that one anything I want. So this is cosine of B. It's already cosine. Secant is 1 over cosine. And cosine is just cosine. So this looks like fractions to me, so I'm going to make my life easier or more clear and make everything a fraction. So I'm clear as to what is the top and what is the bottom. So I'm going to distribute in, so I got to do some math. Distribute in. So remember, when I multiply fractions, I multiply the tops and the bottoms. So the tops would be cosine of B for cosine of B for this first one. And this one here would be cosine squared of B. Oh, look, this is anything divided by itself. Well, that's 1 minus cosine squared. That is sine squared, but we have to make both sides equal. So I know 1 minus cosine squared is sine squared, so I set them equal to each other. You could have also changed this one to be that one. Sorry, if you wanted. Either way, it would have ended being the same. Okay, so now we're looking at this one. This one looks pretty complicated. It looks pretty nasty, but as soon as you see a squared, these guys are all squared here. Think Pythagorean identities. How can I make sine squared plus cosine squared smaller? Well, I know that that is 1. So it's 1 over sine x, and 1 over sine x is cosecant x. Bring that down, make both sides equal to each other. We're good to go. Okay, so this one, we're going to try to get one side equal to the other side, see how that goes. So the only thing I see right now, everything's sine or cosine, but what I do see is I see that this is a squared, and this is 1 minus cosine squared. So hopefully you realize that that is simply, well, it's not that. It is sine squared a over 2 sine a. Okay, so sine squared over 2 sine. What we can do here, make it more clear, you know, sine squared would be just sine of a times the sine of a. Remember, anytime you square something, you just write it twice. So you have a sine a divided by a sine a. Those go away, and I'm left with sine a over 2, which is exactly what this is. So these are equal, and you have to figure out how to make them equal. Okay, so that's it for now. Check that out and see if you can figure that out. So yeah. Okay, so now we're going to try to simplify each of these trig equations, or trig expressions, to one term. So it's either going to be a trig function or a real number. So just one term is what I want. So 1 over cotangent squared, so that you should remember, look it up. You see a squared, think Pythagorean. Whatever. You know what that says. So cotangent squared is cosine over sine, so that should be cosecant theta, but it's cosecant squared. And then we know that cosecant squared, or cosecant, 1 over cosecant is sine. So this should be sine squared theta. So that's one term, and we're good to go. So this next one here, cotangent over cosecant. So cotangent, we just want to make it one term with one trig function. So cotangent, you know, is cosine over sine, and you know cosecant is 1 over sine. If you think of this as a giant division sign, it makes this a little easier. So remember, when we're doing division, this is keep this the same, change this to multiplication, and then flip this. So this is keep, change, flip. So keep this the same, change division to multiplication, and flip 1 over sine. Now these cancel out, and I'm just left with cosine. Amazing. Okay, so you're just doing math and you're trying to figure out how to make this easier for yourself. Now there's always multiple ways to do these. There's never one right way. My way is pretty awesome, but I'm just kidding. But there's never one right or wrong way. Now, one thing that you might be thinking about doing is changing sine squared x to 1 minus cosine squared x. It's an idea. I mean, you see cosine, and it might work. So you can try it. I don't see that myself, so try it and see what happens. But what I see is 2 fractions that needed to be added. So in order to add 2 fractions, the common denominator you have to figure out. Cosine of x is our common denominator, so I multiply the top and the bottom by cosine of x. So what I wind up with is sine squared x plus cosine squared x on the top, and the bottom is just plain old cosine. So sine squared plus cosine squared is 1, and that would be nice bears. That would be secant. Okay, just one way. You could have tried it, making this 1 minus cosine squared, divided that into each, you know, it might have worked, but that's not the way I thought at first. And then finally this one, everything's in terms of sign, so we want to multiply this out. You know, this is two binomials being multiplied together. So this is 1 minus sine A plus sine A, and then this is negative sine squared A. So plus and minus cancel out, and I'm left with 1 minus sine squared A, which, as you all know, is cosine squared A. So these take practice, and when I'm doing them, you're freaking out. Well, stop. Okay, just take it one step at a time. Try anything. Okay, don't just leave it. See if you can figure out, you know, how to change things around. Okay, have a good day and good luck.